So I just checked in on a sample quiz that I posted in preparation for our Trig graphing quiz coming up. And number 29 was by far the problem that we scored the worst on as a class. Not everybody has taken the sample quiz yet, but of those that did, not even half of you got number 29 right. So we need to take a look at this thing. We can fix it, we just have to be careful. So this is a tangent function, and I recommend that you go down and list your important features of the graph before we decide which one to pick out. So I'm talking about things like A, we label A, and since there's no number multiplied to the tangent function, we'll call that a 1. So this, whatever graph we pick, it's not going to be stretched out, taller, longer, thinner. We find the period, and for tangent function, you do pi divided by k, and k is this 2 right here. So our period is going to be pi over 2. The phase shift for this function is going to be negative 5 pi over 6 divided by 2, which is negative 5 pi over 12. That's kind of a funky number. And then there is no vertical shift on this thing either, which just means that that inflection point of the original tangent function is going to be plopped right on the x-axis still. Okay, so we're going to see if we can solve this thing with the period first, or at least rule out some of the choices. So for example, I'm going to immediately cross out letter C and letter D, because both of those, the period is much longer than pi over 2. Pi over 2 is just 2 of the marks on the graph here. And both of these graphs have a period that is longer than pi over 2. That means that we're left with choosing either A or B. And since we've been working on locating asymptotes, and we've got a pretty good strategy along with some notes that we'll be using on the quiz, our little original asymptotes chart, I think we should try and rule out A or B using asymptotes. So remember, for the tangent function, the original asymptotes are negative pi over 2, 3 pi over 2, and 5 pi over 2, and so on. Okay, so I take a look at B and A, and I notice that right here on A, there's going to be an asymptote somewhere between pi over 4 and pi over 2, because every one of these marks is a pi over 4. And on B, there's going to be an asymptote just inside of pi over 4, so just less than pi over 4. So if I can figure out where one of these comes in either just shy of pi over 4 or just past pi over 4, I'll know which one to choose. Remember, we do the old divided by k plus the phase shift to figure out the new asymptotes. So I'll take the negative pi over 2, divide that by 2, that makes negative pi over 4. Then I'm going to add in the phase shift, which is negative 5 pi over 12. Now, that's a whole lot of negative. That ends up being a negative 8 pi over 12, which is like negative 2 pi over 3. It's off the charts. It's off the grid, so that doesn't help me because that's way over here, right? Negative 2 pi over 3 is off the charts, so we're not worried about that one. Let's do pi over 2. If I convert pi over 2, that's going to be positive pi over 4, which is a little bit better, but it's still off the grid because pi over 4 is 3 pi over 12 minus 5 pi over 12. That's just pi over 6, negative pi over 6, which again is not on our chart here. We're looking for something between 0 and 2 pi that's close to pi over 4. So this one didn't help me either. So let's do this last one, which is 3 pi over 2. I think this one's going to help us. When we do 3 pi over 2 divided by k, we get 3 pi over 4. And that's 9 pi over 12 minus 5 pi over 12. And that's going to be 3 pi over 12 minus 5 pi over 12. That's going to be, what did I say this was, 9? 9 minus 5 is 4. 4 pi over 12, which is pi over 3. So that asymptote is just past pi over 4. It's between pi over 2 and pi over 4. So that means I have to rule out letter B, and I'm going to choose letter A for this answer. And we're in luck because letter A is the right answer, so that's good news, right? Now let me just remind you again what we did. You are going to have your old asymptote chart with you during the quiz. If you can't rule out all the options with the vertical shift or the period, then you're going to have to try and figure out where these asymptotes are. And everything that I decided here was based on the fact that if you look closely at this picture, there is a grid line right here where I'm drawing this red line. And the asymptote for this graph is just this side of that red line. Whereas right here, here's the grid line that goes through. The asymptote is just to the left of that. That line happens to be pi over 4, right? If every other line is pi over 2, then the one in the middle is pi over 4. So I took the tangent asymptotes and I just started converting them until I found one that was in that range, right? These negative ones don't help us because they're off the chart. So I ended up having to go all the way out to 3 pi over 2, and I found that that asymptote ended up at pi over 3. And that means that I want the letter A because, if we zoomed in on this graph a little, you'd see that here's the pi over 4, here's my asymptote, and here's the pi over 2. And that this has to be the choice because that's where pi over 3 is. It's between pi over 4 and pi over 2. Okay, so we do the process of elimination. That's why letter A is, number 29 is letter A. Let me show you number 28, which is another one that we got wrong quite often. And maybe this process will make more sense to you. Okay, so number 28, we're also asked to identify the graph of this function. Let's jot down some information. Our A value is 3. The vertical shift, they stuck it out in front, but that's a 2, so that means this graph is shifted up 2 units. The K value is 2, that means the period is pi over 2. And so that's half as wide as half the length of the cycle as a normal cotangent function. And then finally, the phase shift is going to be negative 11 pi over 12. So this is another one with a crazy fraction. We'll go ahead and do that here, but again, I'm going to try to avoid that in the future. Let's see how many we can rule out just with the vertical shift. So the vertical shift is supposed to be up 2. And I can see right here that inflection point is moved down on this letter C. So I'm going to get rid of letter C right away. Definitely not the answer there for letter C. I think that's the only obvious one that we can cross out with the vertical shift. The period is pi over 2. That means the width of one cycle would just be 2 of the squares. I'm just trying to see if we can rule out any of these. If we go from this mark to this mark, that's pi over 2, and that includes 2 cycles. So I'm going to rule out letter A because the period for letter A is too narrow. It's less than pi over 2. And that means it's either going to be B or D, and that makes sense because they look very similar. So let's try our asymptote trick again. And I'm going to zero in on pi over 2 for this one. If you take a look here, the asymptote for letter B comes in just to the right of pi over 2, and it comes in just to the left of pi over 2 on letter D. So if I can investigate where the asymptotes went for this cotangent graph, then we'll be able to pick out either B or D. So just remember that on the row for cotangent, the asymptotes are 0, pi, 2 pi, 3 pi, and so on. And we've got a huge phase shift here. It's almost a full pi to the left. Our period was cut in half, so that's going to be another adjustment. So I'm going to go out on a limb and I'm going to skip right over to 2 pi and I'm going to move that asymptote and see if that ends up being one of these. So the way you move an asymptote is you do the old asymptote divided by k plus the phase shift. And let's do that right with 2 pi. 2 pi divided by 2, that's just going to be pi. And then I have to subtract off 11 pi over 12. And 11 pi over 12, pi minus 11 pi over 12 is just pi over 12, which is really close to 0. So as it turns out, I missed the asymptote that we drew in here, but I found a different one. I found this one. It's really close to 0, but it's on the right side of 0, whereas look at this one is on the left. So just by relocating that 2 pi to pi over 12, I have eliminated letter D, and that leaves me with letter B as the correct choice. Letter B has the right period. There is a vertical shift up 2. It's a little hard to see because this thing was multiplied by 3 and stretched out, but that's where the inflection points are. And we located one of the asymptotes to be at pi over 12. This guy, letter D, does not have an asymptote at pi over 12. It's on the left side of the x-axis. So again, these asymptotes have helped us answer number 28. Okay, so I think the moral of the story is that just because questions are multiple choice doesn't mean that you can look at them and figure out what the answer is. That is not the point of multiple choice. Multiple choice is meant to give you some options for the correct answer after you do the work. And frankly, it also is a little faster to get feedback because we can grade this pretty quickly. So you're going to have to do some work on these graphs by eliminating them based on the information given in the equation. You're going to have to do some calculations too. You can't just look at it and figure out what the answer is. I'm only saying that because I don't just look at them and figure out the answer either. I have to go through the calculations to eliminate some choices and then zero in on the correct ones. Okay, so hopefully this helped clear up these two graphing problems, which we seem to have a lot of trouble on. We already practiced the other asymptote stuff earlier. So if you need me for anything else before we take the quiz, you know how to contact me. And in the meantime, just take care, and we'll say good luck when you take the quiz.